So this problem, what we're going to see is that we can't just factor out an x to begin with, because notice this 20 right here, it's missing an x value. So it's not like before where we can factor an x out, and it's not a trinomial, so we can't factor it using the diamond method like we saw before. So what we're stuck doing here is either using a division method, which like I said in this section we won't see, or we could do grouping. So this one's going to require grouping. So let me show you how grouping works. Really cool method, but if you haven't seen it before, it might take a little bit of time to think about what's going on. So we have x to the fourth plus 5x to the third plus 4x plus 20. So what we're going to do is we're going to split this into two groups, and this Khan assignment, it's really simple. They show you they've already put everything together. We don't have to rearrange anything. So we have x to the fourth plus 5x cubed. That's our one group, our group on the left, and then we have a group on the right, 4x plus 20. So we're going to look at each group and see if we can factor something out. So between these two, if you look at this left group, kind of separate it, just look over here, ignore everything on the right. What can we factor out? Well, we can factor out an x cubed. So that would leave us with x plus 5. And it's not always that you're going to see something able to be factored out of a group. It might just be left that way, in which case you can factor out a 1. That may be a good idea, so you can use it as a placeholder. Let's look at the right-hand side, though. So these both have a 4 in common, so I'm going to factor out a 4 and be left with x plus 5. So what I did there was I factored something from each group, and now look at what's left. If you look at this, this must be the case. You must have that these are both the same. If they're not the same, then it didn't work. So since they're both the same, x plus 5, think about this. If we were to rewrite this over here, let's just exchange the x plus 5 with an a. So if we have x cubed times a plus 4 times a, which you could picture is that both of these have an a in common. And what I can do is I could factor out that a to the front and be left with a times x squared plus 4. So you could kind of picture that just being factored out if it was a. Well, we don't have a, instead we have x plus 5. So the same idea, we could factor that x plus 5 out to the front. So in the front, I'm going to put x plus 5, and then what's left on the inside is x cubed plus 4. It works just like what you saw over here. It would be, you factor out the a and you'd be left with x cubed plus 4, just like we had there. Oops, I put x squared. Now that you're here, you should check each factor. Sometimes you can factor them again. Like if this was an x squared minus 4, it would be different. Then you could factor that again. But you can't factor this out. Neither can you factor this. So the problem is done at this point.